So let's look now at distance and time, quantities you're probably already familiar with. Well, when we're talking about distance, distance is really just the space in between 2 points. How far it is between 2 points, wherever those points are. The thing about distance is it's commonly measured in meters, and when we study physics we're going to measure distance in meters. There's also units like millimeters, centimeters, kilometers, etc. Doesn't really matter, it's all going to be some version of meters. The thing about distance is distance depends on the path that is taken. So if we're looking at this picture, if John is trying to get to his grandma's house, the path he may take may be in a canoe across the lake. And clearly that's a shorter distance than the path you take if you go around the lake. So it really depends on the path that you take. And we can apply this to our real life. Distance depends on the road you take, whether it's sidewalk or whether you're cutting across a field. The distance depends on the path that's taken. Now distances can be measured very, very small, and if we look at a CD or a DVD, the tracks on a CD or DVD are very, very small distances apart, 1.6 times 10 to the negative 6 meters apart, or it could be a very large distance such as 1.6 times 10 to the 9 meters, the nearest star. But notice both of these are measured in meters. We just have scientific notation that gives us an either very small or very large distance. Time is also a quantity that you're probably quite familiar with. And when we're doing time, what we're doing is we're measuring the duration of an event, how long it takes, whether it's seconds or minutes or hours, days, years. There's a whole bunch of measures of time that we're going to use or potentially look at. Now, when we're talking about time, we often refer to time as a time interval. And it's given this symbol delta t, triangle t. Now, that triangle really represents delta, meaning change in quantity, delta time. So if we were looking at a time, we usually start at time 0 and start our clock and see what the time interval is for something happening. As we study more and more into physics, we're going to use a lot of graphing and a lot of graphs. And the reason we do that is graphs are used to illustrate the mathematical relationship of two quantities. So we can take two quantities, we can measure, find the numbers, count the numbers, whatever it is, and then we can graph them. If these two quantities are directly related to one another, the graph that we're going to get is a straight line, much like this picture. And this straight line is actually a very, very useful component of the graph. The slope or steepness of the line gives us a quantity, a related quantity. And we can find the slope of the graph just by finding any 2 points and then dividing the rise by the run. And the rise and run are really just the distance between those points. Rise is how far up we've gone. Rise and run is how far over. So in this picture, we would have to rise and run to get to the second point. Now what we're going to start with, and the types of graphs we're going to use, is we're going to graph distance and time. And if we graph distance and time, put distance on the y-axis and time on the x-axis, we can find the speed of an object. And that's what we're going to start out with. We're going to graph distance and time and find the speed of moving objects.